Hi, today I want to talk to you about U.2 NVMe drives and how to connect them to your NAS. When I first started thinking about what kind of storage I wanted for the NAS, I knew I wanted something that was fast and very responsive, which is, as an editor, everything. It's gold. It's important to be able to stop, play back, fast forward as quickly as possible, make sure it's snappy, and that I can do this not only with proxy media files, but if possible with raw media files when color grading and using source footage, when onlining things. And the reason that it's not just for playback in the sense of, a good user experience, but also to catch mistakes. If there's any skip frames or anything funny going on, it's meaningless to have really fast speeds if after, extended use, suddenly your speeds drop down. And this is true both during renders or when transferring or managing media and archiving projects. You want consistent speeds to be able to predict accurately when things will be done, so that when you consider your timeline, your schedule, your budget for a job when you're bidding, you don't overpromise and you deliver on time, if not early. So with all that said, that is why I decided U.2 NVMEs was something that would be great for a NAS. This comes with a few setbacks. Not only are the drives more expensive, but the infrastructure you need to run them. Your NAS CPU has to have a higher clock speed. It has to have more PCIe lanes available to your NVMe drives. The cabling is more expensive. Everything becomes a little bit more complicated and expensive when you're dealing with NVMEs, which is why also when it comes to turnkey or customer solutions online, there's not that many options that use NVMEs, and the few that do always tend to use the U.2 form factor. There is a newer format, I believe it's called ESF. I'll put the name up. They're more designed again for a server room or an enterprise solution, where it's about using the space as efficiently as possible, as compact as possible. Noise is not something to consider. Whereas U.2 drives are very similar in their form factor and how they dissipate heat to regular SATA SSDs or hard drives. And so it was a more familiar and comfortable transition for me while using these faster speeds. Coming from this angle, I knew the CPU I needed. I knew I needed as many PCIe lanes as possible on the CPU I was going to use and the motherboard that I was going to install it on. But what about the actual connection between my motherboard and a U.2 or several U.2 NVMe SSDs? There's a few options on how you can connect a U.2 NVMe SSD to your motherboard. Some motherboards might actually have an SFF8665 port available, in which case you could just use one of these cables and connect it directly to your motherboard, and then the backplane or container solution you're using for U.2 NVMEs. You can also have a cable that goes from an SSF or SFF8665 connection directly to a connection for your U.2 drives. Or when you're dealing with many drives, you might need something to be able to get more connections from your motherboard to a container. Like in this case, I was using for roughly 6 months this ICYDOCK container. And this one comes with 3 8665 connections, as you can see right here. And so that's one option, using a container like this. So you can either have a cable going from a PCIe lane directly to your U.2 drive, or perhaps you have a port on your motherboard, or you can use an HBA card. So what you do is you have something like this. This is an LSI Broadcom. I'll put the name of the model. And what this does is it has 2 ports, just like the ones, that single port I had on my motherboard. And they also can connect with an 8665 cable like this one. And so what I do is I have 2 of these, plug in with cables, and then plug in along with the third one from my motherboard in here. And this allows me to see all 6 NVMe drives on my system. The only problem with this is that the one cable that goes from directly from my motherboard to the NVMEs on my first row, and the way I set it up, it saw the drives directly. Whereas the other two cables, the ones that are connected to the HBA, there's a barrier or a layer between the NVMEs and the CPU, which is the HBA, and it's the way it manages things. And this is not necessarily a bad thing, especially when it comes to hard drive. It's a good thing when you have an HBA connecting to a backplane with 10, 20 or more drives. And the HBA is something that's great. It helps you manage things and overall make the system more reliable. But when it comes to NVMEs, you really don't want something between the NVMe and the CPU. They work best when it's a direct connection in any kind of software RAID or true NAS setup. One of the disadvantages of this approach is that it has a lot of complexity. And that is, you need an HBA, which adds that barrier, kind of describe that layer in between your NVMEs and CPU. It is expensive. HBAs, even if you buy them used, can cost $500, $600, $700, or if you buy one brand new, I believe this model new is around $1,000. It's very expensive. The cables themselves are not cheap. I'll put the price for them as well. And in this case, this ICYDOCK container also was not cheap. It was $400 or $500. I'll put, again, the price up. You'll notice that this particular HBA is only 8 lanes. It's not the full 16. And they, at the moment of the recording of this video, for this particular design, they don't have a 16-lane version. They have another 8-lane version with, I believe, 3 or even 4 ports, and that works fine, but each NVMe drive that would be connected to something, let's say like an ICYDOCK or a backplane, each of your NVMEs is not running by 4, but it's running by 2. There's another option that I haven't mentioned yet, and that is PCIe to U.2 adapters. And this is the one that's usually the most recommended on forums and online, but usually if you look online, it's always for a single U.2 NVMe SSD, or sometimes 2. And it's very rare where you see one that has something like this model from DeLock, which is by 4. And it uses all 16 lanes. So you have by 4, by 4, by 4, by 4. And this is ideal because you use the full capacity of each one of your precious PCIe lanes to get the full speed from your drives. The other advantage of something like this is it's much cheaper because unlike a RAID card or an HBA, there's no, I guess you could describe it as brains. There's no logic going on the system. This is more similar to something like a GPU extender or GPU riser, I guess they call them. This is not to, speak badly of DeLock. The design and work they put into this is great, and it's very easy to use. But essentially, yes, this is just extending. If you look, you can see here the traces, the wiring, the traces that go, and they translate the 16 lanes into 4 by 4 by 4 by 4. But because of how simple this is, because it's not an HBA or a RAID controller, this system relies that your CPU and BIOS and motherboard support bifurcation, because your CPU and motherboard are the ones that have to decide how the lanes are distributed, and not every CPU and motherboard support that. So you have to make sure either when you're buying your motherboard and CPU that they support that, or when you go in this direction that your existing motherboard and CPU support that. And if they do, it's great, because you just go into your BIOS, set it 4 by 4 by 4 by 4, and there you go. You have 4 connections, and the only cabling you need is here on the back. Actually, you can see a single basic what do you call it, SATA power connector that you use for any regular hard drive. You just need one, and you're able to power all 4 power-hungry NVMEs just fine. And again, because this is only $150, I could buy 3 of these, and with shipping and tax, it costs me roughly $500, where The ICYDOCK container alone was $500 without the HBA, which is another $1,000, and the cables plus shipping plus tax. So yeah, so in hindsight, I wish I had purchased the model from DeLock, but whenever you jump into a new hobby, you research the forums, you're bound to miss a few awesome solutions out there. Now, this is not to say this solution is not good. This is a solution that allows you to have hot swap ability. So if anything happens to any one drive, you don't technically have to power down your system. You can pull out the drive, it's an issue, put in a new one, and you're off to the races. But I personally, and I'm guessing here, I don't know for sure, but to me it seems that when ICYDOCK was designing this, they weren't designing this to be used 24/7. It's more, I believe, designed to be slotted into a desktop PC, not even a server rack, and to be used as like a software RAID on like a PC box, where these drives are hit and used for a render for like local storage, but they're not running 24/7. And so they might get hot temporarily, but then cool off at night when they're not being used. And so that is why they went with this compact form factor, because they originally thought, oh, this is great, I can turn this on the side, put in a server rack, and like populate a lot of these. But obviously you have to be careful of not trying to reinvent the wheel. You look in the enterprise space and they hardly ever put the drives in such a compact manner, and when they do, they have really loud fans pushing a lot of air through, because with a system like this, NVMe drives always run hot, but this definitely was on the hotter side of things. It still was within spec, and unfortunately these fans, which I replaced these, the original fans were the same form factor, but these are Noctua fans. They're slightly more quiet. They're still quite loud, even after I used the low noise adapter that came with this little cable that came with the Noctua fans. And all it does is really drop down the voltage, so the RPM of your fans is a little slower. In fact, what I ended up doing before I found and tested the DeLock system was actually put a fan in front of the hot swap bay, which kind of defeats the point of the hot swap bay. And immediately my temperatures dropped by 10 degrees, which is a lot. And that made me realize two things. One, which is that I don't actually need hot swap capability, because whenever I do maintenance on the system, I power it down, I shut it down. And I don't have to run a lot of maintenance on the system. These drives are very reliable. They run 24/7. I never have issues with them. TrueNAS, the way I set it up, it's very simple to use. So yeah, I definitely learned from this experience using my wallet, and I hope others watching this video or whatever I post online are able to save the time and the money to use something more appropriate for them. And again, this might be appropriate for some setups, but in my case, I found this solution to be much more elegant.